All right, good morning all. Today we're taking a bit of a deep dive into the subject of fire safety. It's a pretty big topic here. As Scott will mention, there's not a lot of it in the New Zealand Building Code. And I guess one of the biggest things to what we've seen in the construction industry in New Zealand is the inclusion of insulation to the outside of the structure. Now, for little old New Zealand, it's probably been the biggest innovation to construction since the invention of the nail gun. So it's quite new to us, and we do find everyone, we want to be here to supply solutions for everybody, including fire engineers. So this is what today's topic is about, specifically around fire safety and how we can prove compliance. So today I'm joined by Christoph, the product manager from IKO, and Bart, who's the export manager. We're going to talk about how they prove compliance in Europe. And Bart's also going to touch on some actual real life case studies of how it actually comes about. So yeah, we're going to crack on with the presentation. We just want to flick through the first slide. We'll introduce the first one. So it's a great opening picture here. This is Westgate Library, class 4 type building. It has an insulated tapered Nuralite warm roof on top. So this building's probably built around 8 years ago today, as of today's day, just to prove that we can actually do these types of buildings. So we're going to touch on to the next slide here now and introduce Christoph as he talks about some building design elements around fire safety. Christoph.
Yes. Before we start, we certainly wanted to add a little bit of a general context into what we will be covering today. So today we will talk about the building design, but it's important to be aware that building design is just one small aspect of fire safety. We are going to talk about products and systems, but let's not forget the technical appliances to, for example, sprinkler installations. Let's not forget about building management. What about evacuation when a fire occurs? How does the fire brigades access the building? And who will initiate fire extinguishing activities once problems occur? So all of these questions still need to be asked. Today, we talk about building design. And in the next slide, you will see that building design is all about 3 main properties, product properties or system properties. We are talking about reaction to fire, meaning how much will a product or a system contribute to a fire. We will be talking about fire resistance, meaning how well will a structure or a product or a layer resist to a fire source. And then we are also, and very importantly, talking about flying brand, meaning how will your flat roof protect your building against a fire source. So all of these we will be covering today. And in the next slide, it's important to explain when these are coming into action. So we see here the ISO curve. An ISO curve is actually the development of a fire in a standardized way. We have on the y-axis the temperature and on the x-axis the time evolution. And we have these 4 main phases into fire development. You have a starting fire and the incipient phase. You have then the growth phase. Then you have what's called a flashover. Once there is so much heat that your fire becomes fully developed. And then you have the decay phase, meaning your fire will gradually disappear or reduce. The reaction to fire and the flying brand are important at the beginning of a fire, and the fire resistance will mainly be important once we are talking about a fully developed fire. Why is this important? because if your system has a good reaction to fire, that will potentially avoid the fire from further developing.
Yeah.
Avoid or less quickly develop. On the other hand, if you do have a fully developed fire, if your system has a good fire resistance, then it will be capable of resisting this fire for a certain amount of time.
I think on this next slide here, we've seen a pretty good example of three separate, well, there's one building, but there's three separate Nuratherm warm roofs.
Mm. Yeah,
Scott,
Shane.
you familiar with this project, mate?
Yeah, so these are it's a Kāinga order development in Auckland by Mode Design, and in the middle and the right-hand side there is the tapered, so preformed slope PIR insulation board with Nuraply 3PM membrane, so the two-layer membrane. The roof on the left-hand side is the it's a lightweight metal tray substrate to fall with flat PIR insulation board and the same two-layer bituminous membrane system on top.
Nice.
Yes, and the question then obviously arises, how do you evaluate these roofs? The general concept of evaluating the fire safety of a warm flat roof is it goes two ways, as you can see. You have the fire from the outside to the inside, meaning there is a fire source on the outside. How good will your flat roof protect your building against fire from the outside? And then also important is, of course, once you have a fire on the inside of your roof, how well will your roof protect or will it be protected against a potential fire source from the inside? This is what we will cover in the next slides. So on these three levels. So let's start with some of the system properties we see here of the Nuraply 3PM system. We see the B-roof T1 on the membrane. It's important to note that this is a test being performed on the membrane, but always in combination with a certain substrate. So in this case, that will be a PIR insulation. We also see that the IKO, the Nuratherm PIR board has a certain reaction to fire properties. We see the Euroclass E, for example. That's so the so-called end-use test. And then we have the flame spread test, which is done standard in the Euro classification test, but there is also a separate British standard 476 test, where the insulation scores class 1. And then to go further to the substrate, in this case, concrete substrate with an REI or fire resistance of 60 minutes. So let's dive a bit deeper into what all of this means. So to start, fire from the outside to the inside, we have the B-roof classification, which explains the performance of the flying brand. Flying brand will or can occur once you have a fire in a neighboring building. You remember the picture that Scott has been talking about. You have these apartment buildings, one next to the other. A fire occurs in one building. Of course, you want to avoid that building 2 or 3 are affected by that fire. Therefore, the B-roof classification comes into play. But it could also come into play when you have, for example, a fire in the same building, and your roof protects a fire spread to another part of the same building. So those are important phenomenons to avoid. So that's what B-roof classification is all about. How is this tested? Let's take a look at the test method.
This is the fun part, right? This is how it's tested.
Yes.
This is the fun part. Yeah.
Putting things on fire. So the B-roof test is generally a fire source put on top of a roof, slight inclination on the substrate, and as you can see here, it's a test on a bituminous membrane, which is put on top of a PIR insulation.
Mhm.
You also see all those lines on the right side after the test. So just to clarify, you want to make sure there is a few parameters that are being evaluated here. You want to make sure that your the fire hasn't spread over the surface too much. That's the first thing. So this is measured. And second of all, you also want to make sure that the depth of the fire and the damage inside the whole structure is also limited. These are the two main aspects in a B-roof test that are being evaluated. This is a B-roof T1 test on the left side. So a fire source which is put on a roof. And it has, of course, an effect on the full complex. There is also other tests, which is the B-roof T2, T3, T4, which are in general asked depending on the geographical area in Europe, where there is also a possibility that they add extra airflow, where they add extra infrared heat, for example, or they test it on a bit on a larger scale. However, the B-roof T1 test is a good starting point. There is no such thing as one test is better than the other. It's just a matter of having a comparison basis. So in this case, the B-roof classification is, of course, important on the Nuraply 3PN membranes because they prove that the membranes have a good performance on top of different substrates and certainly also on top of the PIR insulation, the Nuratherm boards. Let's go to the next slide where we also show the importance of the composition of a flat roof membrane. In this case, we have two torches who are heating up the bitumen membranes. It's a two-layer bituminous system. And you see clearly the difference between, on the right side, a B-roof tested membrane, which has a better performance than on the left side. The big difference is that on both sides, they are self-extinguishing. That's quite an important property. On the right side, a bit quicker than on the left side. That has to do with eventual graphite that is being added to the formulation of the product to make it have a better fire performance. So this shows into practice what you just saw, how these products perform under influence of flame and heat. So we have now covered the B-roof classification, explaining the importance of protecting your building against the fire from the outside to the inside. Another important parameter is the reaction to fire. In Europe, this is put on a scale from class A to class F, also called the Euro classification, where A is non-combustible or limited combustible, and F is easily flammable.
Sorry to interrupt, Christoph. Have you got some examples of the types of insulation that would basically fall into those categories? Is there just to sort of paint a picture out there what what type of
Yeah,
insulation products would be an A, which would be an F kind of thing, or?
yeah. I will also come back to that question because there is an important remark to give about the
Okay.
question itself. But the Euroclass A is in general the so-called non-combustible insulation products. So an example would be a rock mineral fiber. Euroclass B could be a phenolic board, for example. And then you have the Euroclass C, D, E, F, which could be a polyurethane product. Most of the polystyrene boards are rather in class F or in class E.
Yeah.
But I do want to give a little bit more nuance about this question, because
Sure.
there is no such thing as a fire-safe product, meaning you can have a product which is in Euroclass A that doesn't necessarily in the application have a good performance. So bear in mind that Euro classification is, of course, being tested on products, but also on systems. And that's what in Europe, we see a shift from product reasoning to system reasoning. You will see that
Sure.
PIR boards have don't really have the best Euro classification on product level, mainly DEF. That's not great, but it's important to state that this Euro classification is not representative for the end application. That's why we, as a manufacturer, always aim to test the products in end applications. For flat roofs, for example, you will see that you have two possibilities. So what we learn from this Euro classification scale is certainly that the performance on product level is not representative for the end-use performance. That's why we do have two choices of to test. The first one is on product level. Of course, as you can see, the Euroclass is limited. It's not the best performance because we only test on the installation product. But again, it is important to test the product in its application. This way you have the right and the representative performance of your product on the roof itself. So in this case, we will test in the application, where we test the product in combination with steel deck. That is the so-called end-use test. We have explained this before, so we are testing here fire from the inside to the outside. What are we testing? When we are talking about reaction to fire, there is in the next table, you will see that the Euro classification is, depending on what you want to achieve, will require certain test methods. For PIR installation, which will achieve in the end use or on product level between Euroclass B and E, you will see that the two main test methods will be the single burning item test and the single flame source test. In the next slide, you can see how that looks like. So the single burning item test is a test like this. It mimics the presence of a garbage bin, which is filled with combustible material, which is set on fire, and then you will see how the fire will propagate in on this buildup. Important to note, in an SBI test, you will measure mainly the heat production. Heat production is a measurement to define how much yeah, your material is contributing to the fire. The more heat, the more contribution there is, obviously. And you will also measure the smoke, the amount of smoke and the droplets. So that's one test. This can happen on product and system level. Again, we advise to test always in the application. And what we see on this slide is a single, so a small flame test. This is a torch, a small gas torch, which is, it's a standardized test. You expose 6 to 8 sides of the insulation board to a small flame for 15 to 30 seconds, 15 or 30 seconds, and then you will measure the flame height. Of course, you need to achieve a certain flame height, a maximum flame height, in order to be able to classify your product in the Euro classification. So this is, of course, a test that is being performed always for Euro classification testing. It's a small test. But we also see that there is an alternative in the British standard. And this is in the next slide, you will see the test report, the BS 476 test, which is the flame spread test. Here it's a bit similar to what we do in the EN standard for Euro classification. You will also have your product being exposed to a flame, and you will measure how far the flame will travel on your surface. So similar to the B-roof testing, where you have your damage on your sample, you will do that as well in this test. Interesting to note is that we have the best classification here. So it also shows that the Euro classification on product level is merely one test, one way of looking at things. If you look at the flame spread test, you see that we achieve class 1, meaning that it's not helping the flame to spread further. So also to take into account that you have test methods and interpretations. We tend to look at Euro classification on product level, which is not giving the full picture. Let's go to the next slide. So here you can see that we have the class 1 on the LU board, the Nuratherm LU board. Yeah. Important in these test reports is to always respect what is written in the reports. For example, what you will see here is the definition of a nominal thickness range. In general, in data sheets, this is not always mentioned. So it is worthwhile to ask for test reports wherever possible, because in the test reports, you will have a clear idea of which products have been tested, what is the application domain of these products, and which thicknesses are also covered. So that's what you can see in these reports. They are always available on demand.
Yeah, so for anybody who's out there listening and they need a full copy of all these reports, of course, Nuralite has them all. So if you need them, make sure you sing out, and we'll be able to provide you with the full documentation.
So you see on the second page, you see, of course, important the classification itself, which is BS2D0 for the end-use test with steel deck. And you also see the field of application. So there it is important, for example, the dimensions of the boards. Is there any limitation on joints present or not? In this case, there is not, but be aware that there is more to it than just putting a PIR board on a certain substrate.
Yeah.
So we have now covered B-roof or flying brand. We have covered the Euro classification or the reaction to fire and the flame spread. And now we have come to the third important element to take into consideration in building design, and that is the fire resistance. Also, explained in the REI classification scale. We have our B-roof classification. But
Right.
what is fire resistance? There is actually 3 parameters that are being evaluated when we are talking about fire resistance. You have the load-bearing capacity. So when there is a fire, how long does your load-bearing structure remain or keep its function? You have the integrity, meaning how long does it take for flames to cross the substrate? And then on the other hand, you have the insulation. How good does your structure, your roof floor slab, how good will it resist the heat from one side to the other? All these parameters are checked, and then you have a certain performance, which is then indicated in minutes. So REI 30, for example, means that you have a full fire resistant structure for 30 minutes. It will keep its stability. It will remain close to potential flames, and it will also keep the heat out or in this case. So this is quite an important one because the REI is protecting your roof inside, outside. And that's what we will also see in the next slide.
I think that's interesting that the 30 represents the time the fire department has to drive from their fire station to, because you have these times in countries, like the fire department takes in general this amount of time before they arrive. And I think that's what 30 is the minimum is the standard. Is what is minimum required, I think. No, Christoph?
Well, it depends on national regulations, but in general, there is 2 reasonings behind fire resistance. You have the caloric value, mainly for industrial buildings, depending on how much caloric energy is stored in the building, you need to achieve a certain fire resistance. Also, depending on the size of the compartments in the building, you need to achieve a certain fire resistance. But for a flat roof in general, the fire resistance will merely protect the roof buildup from catching fire, meaning that you don't necessarily need to evaluate the reaction to fire, because as we saw I didn't discuss that, but you have the ISO curve. And as we see in the ISO curve, there is no such thing as a beginning fire in a flat roof if you have a fire resistance.
So obviously flat roofs are a fantastic supporting substrate for plant equipment, and with renewable energy, photovoltaic, solar arrays, and we're definitely seeing a lot of big roofs with big solar arrays on top. And as you can see here, it's being used domestically on a residential project on the 2-layer bituminous membrane system on PIR. We do get asked quite a lot, Christoph, by project fire engineers just around any special considerations or factors pertaining to having solar on top of this warm roof system. And you talked previously about the B-roof testing. Would that be applicable for a local project fire engineer considering performance of the system where solar is put on top?
Yes, it's a question that we also get it's quite a mainstream topic now also in Europe. This is mainly coming from insurance companies who are asking questions about not only questions but making remarks about the use of B-roof classification for photovoltaic roofs. Because as we have already discussed on several occasions, the question arises: is the fire propagation similar on a roof with PV panels on top? So given that it's a very important topic, the industry of PU manufacturers, which make part of the PU Europe Association, have organized a research campaign to make a comparison between the presence of certain substrates underneath different photovoltaic panels. So the scope of this research, which you will see in the next slide, is to have a better insight in the fire performance of the thermal insulation products in end-use conditions. So as already explained before, the application is very important. The fact to have an idea about the performance of the full buildup combined with photovoltaic panels is, of course, of the essence. And in general, the idea is that changing your insulation underneath these photovoltaic panels, which was the idea of several insurance companies in Europe, was the best way to tackle any fire risk. Because the idea is, if you put incombustible insulation underneath, you are safe anyways. So we wanted to prove that this is not the right way of reasoning, and that our PIR insulation can perform at least similar to PIR to mineral wool insulation underneath. So this was a comparative study between PV installation on top of a roof buildup with mineral wool and a roof buildup with PIR. So this is the test, as you can see on the left side, the test buildup. So there is a gas burner underneath that of course ignites the solar panels. Important to note is, of course, the composition of the solar panels have a very important impact on potential fire hazards. The PE-backed solar panels, of course, tend to be a higher risk than the glass-backed panels. So in this case, of course, we did a test on the PE-backed panels, which is worse performing. I mentioned this because it's not only the roof buildup that is important, but also the choice of the solar panels. And on the bottom side, you see the general buildup. On the bottom side, the similar test buildup with PIR. On the top side of the picture, you see the same buildup with mineral wool. So what is the difference in these buildups? It's the insulation thickness. So in order to reach the same R value or thermal resistance, the mineral wool has been installed with a similar performance. So this research is covered in a fact sheet with reference 24E, which is available on the PU Europe website. I will quickly go over the findings of this research, but be aware that all the details can be found in this report. So what do we see after the test? First of all, so on the left side, you see some images right after the test. So we see that the damage to the waterproofing layer and the top surface was similar for both the mineral wool roof and the PIR roof. So that's already an important finding. On the top side, you see the buildup with the photovoltaic cells still present. On the bottom, they have been removed for a clearer view of what happened. Next slide, you will see the buildup without the waterproofing layer. So top, you see the affected area after removing the waterproofing. And you see on the bottom side, you see the depth of the fire damage. So first of all, if you look at the surface of the flame spread, it is also quite similar on the top. So it's different in shape, but the surface is quite similar. On the other hand, you see the depth of the fire damage on the insulation layer. There you see that there is a charring layer on top of the PIR insulation. This charring layer is actually a good thing because the charring layer will also form some kind of protection layer against the fire on top from further expanding down. Yes. And this is quite an interesting find, which we saw during the opening of the roof. So we removed, well, we didn't actually do this. This was done by an external lab, but the insulation boards were removed. And you see that on the left side with the PIR, you see some black traces, but that's just the charring from the installation on top that fell on top of the vapor barrier. But the vapor barrier is actually unaffected. On the right side, you see that the heat was able to travel through the entire thickness of the insulation, and that the vapor barrier has been affected by the fire. So that was certainly an interesting find. Yes, next slide.
So that's a contrast between PIR and mineral rock wool, is that right?
That's certainly a contrast. Another finding was that so the core of the mineral wool was upon demolition was still warm. And that's something that in general fire departments don't really like. It's the concept of a smoldering fire where you still have the energy which is captured into the buildup. So
can I add something? I think with mineral wool, the lambda value is given by the air between the fibers. It's an open cell structure, so fire needs air. So this air is inside the mineral wool. That's how the fire came to spread inside the mineral wool. While with polyiso, you get a carbonization effect. It's a closed cell structure, so there's no feeding of air. So the fire tends to go out. And I think that's the main difference, what you see here in this picture, that the fire was able to go through because of the air, and it wasn't able to go through because of the closed cell structure in the polyiso.
What in general, what can we learn from in general? What do we advise to people in building design and construction, being busy with creating flat roofs, putting them onto the job site? Well, first of all, fire safety is a holistic principle. We started this presentation with the zoom in on the building design. Don't forget all the rest. It's the Modern Building Alliance in Europe has a really nice concept about this. It's called the bio framework. So there is building requirements, but there is also requirements on installations. There is organizational requirements. So it's important to have a look to the subject of fire safety, which does not just focus on the building, the systems and the building itself. The next important lesson is that a product evaluation is insufficient. We have seen this throughout the presentation on the Euro classification on application level and product level. We have also seen that during the overview of the study by P Europe, where you see that an incombustible installation in the application does not necessarily have a better performance. And we also saw in this presentation that it is very important to look at the right details. Fire safety is a very complicated subject with a lot of details. So it is important to consult and comply with the latest fire regulations. Scott outlined this at the start of the presentation for flat roofs in New Zealand. The building code is very limited, but that might still evolve. Anyways, fire regulations keep on evolving. So do not focus on regulations from 1992 and stick with them, because they get updated every few years. And then a fourth, but equally important lesson is the fact that the fire performance of a product should be based upon facts. Facts, and as a consequence, on testing. So testing can only be proven by test reports, and these are available with the respective manufacturer. So there we go.
Excellent.
Christoph, thanks a lot. That was a very complex matter explained in a understandable way, because there's a lot of people saying a lot of stuff, but it's not always based on facts. So the reason why I'm here is to make a case study, because the best way to show something is how it actually performed live. And this is a fire that we had on one of our roofs in Estonia. When you are building a warehouse or any other type of building, the fire department or the fire specialist has to give his green light during construction that the materials that are specified can be used. And like Christoph was saying, people tend to use at the fire behavior of a product and not the product used in a system. What I am presenting here is a case study as an actual fire that started on a roof. So in the pictures, you see materials being stocked on the roof during construction, like wooden pallets, leftover material, gas bottles, all put together. So what happened in this case, because there's not always enough room to put everything, but they use the roof also as a stocking area. So in this case, the left picture is an actual picture on the roof of where the fire happened. At the end of the day, the roofer, they were going home. It was 5 p.m. He left his torch, the wake flame, on, and he put his torch next to the stock of the other materials. So what happened is that the wooden pallets caught fire, and they started to ignite, as did 3 or 4 of the gas bottles exploded. So immediately, because the fire department knew there were gas bottles, there were people, they immediately warned the entire department with the highest alert there's a major fire going on. We have to go to the job site. As you go to the next slide, you see that because of the idea that polyiso is not safe, they sent the whole fire departments, including on the next page, you see that they were afraid that people would get hurt. But yeah, the people had already just left, but didn't really matter. Because when they arrived, if you go to the next slide, they were pretty disappointed because most of the fire was already out. Now, of course, I'm a little bit joking. But if you looked on the next slide, they were actually enormously surprised that the fire went out so fast. And actually, when the fire was out, there was almost no damage to the structure. So
can you give us sorry, Bart, can you give us some sort of sense of scale on this? Like we're looking down on a roof, and can you give us a bit of a sense of scale here?
Yeah, so it's a 15,000 square meter job, where 3-4 gas bottles explode and a number of wooden pallets were burning. So actually, this is a live example of flying brand. So the fire didn't spread, it didn't grow to the structure because the bituminous membrane protected also the whole system. And the end result is that the effect of the fire, including exploding bottles and wooden pellets on fire, there was almost zero to no damage, except for a little bit of black carbonization of material that had been burning. So then we go to the next slide where you see with a little bit of cleaning, the next day, 2 days later, a little bit of repairs, they were able to continue the roof works and were able to finish this roof. And this is the same roof that had been on fire like a couple of days before. Of course, in this case, they also applied the solar or the PV panels after. And also something, not just the fire performance of such a roof, but one of the major reasons why they also choose polyiso is because of the compression strength. If you would use, for example, mineral wool, you could not place this type of PV panels on the roof because you could intention of the insulation. And this will not happen with a very strong PV panel. Another thing which is important to add is that when you are installing the PV panels, you will not damage, or the damage is done because there's a lot of people, there's a lot of sharp items. The polyiso is very strong, including with the bituminous membrane. You will have little or no repairs to be done on this roof, so you will have a perfect result. So in the end, the conclusion was that the fire department was so surprised by the result that as of now, it has become very easy in Estonia to get a specification certified by the fire department when polyiso is being used. And as a result of that, we have been able to score a lot of nice objects in Estonia. If you go to the next slide, there's some of these examples. This is one of our latest additions. This is a Kabamaya web shop, also including with the PV panels. On the next slide, you see the first IKEA building. This building is in front of the Maxima department store, a distribution center, which was the first object that we did. And on the next slide, you see the depot store, which also is the same application, the same roof system, and we will have many more to score. Also, I think the same will be happening in New Zealand. Thanks to you guys. Thanks. That was my addition.
Yes, thanks. No, that's great. Thanks, Bart. It's that's really good to see. You know, got the very, very deep diving theoretical testing results and all the technical information, which is extremely important. Which makes the you know the proper players stand out amongst the field. And then when you see that translate through to an actual real life building, I think it's a great way to tie it all together. And I am impressed with all those solar panels. I think that's fantastic. Something we should be employing here for sure. So,
no, I think it's really good. I think you guys have been really clear. It's concise.
Yeah.
I think we've touched on
the
fact there's all the test data, and we're transparent with the test data, which is what the engineers, everybody wants to see.
You guys happy with it?
That's the main aspect there, that you don't look at the fire performance on the product itself, but you have to look at the results in the system. And that's where the polyiso can make a big difference. While other manufacturers of mineral wool, they tend to focus on the reaction to fire of just the product. And and in the system it doesn't perform as well.
All right. Thanks very much for listening to our little presentation today. I hope you've learned a few things about fire safety. I hope we've actually proven the fact that we can do these big, scary buildings with external insulation and have those high-performing buildings and make them comply and keep people safe. Just to the listeners here in New Zealand, this presentation is accredited for 10 NZIA CPD points. So feel free to apply on the link and we'll be able to get those out to you. Thanks again to listening, and thanks again to Scott, Bart and Christoph for your time. This is a little bit more of a deeper dive than we normally do in our webinars, but I think the subject absolutely needs it. So thanks again, and we'll see you on the next one. Thanks very much.